So this focuses on, we're now in a position where Ulster have MS-2 phage, Hector has MS-2 phage, and we grew it over the last 3 weeks. And Natalia now has MS-2 phage and will be growing it over the next few weeks. So this there's background information which you'll all know now from Natalia's presentation. But this is just basically an update and a summary of the growth protocols, just because it's timely, and just an update on some of the protocols too. So the reason why we're testing this is the devices we're putting into the communities. We would like WHO international approval, and that's a harmonized protocol that we follow, and MS-2 is in that. So basically, you cannot set performance targets for all waterborne pathogens. You can't test everything. So what has been chosen are treatment indicators, if you like. So we have bacteria, E. coli. We have viruses, MS-2 and 5X174. And we have protozoa, Cryptosporidium. We spike them in at really high, crazy concentrations that you would find far higher in the environment, so that you get your log reductions. So you basically want as high a log reduction as possible. And what we need for the viruses are 5 log reductions, and your equipment is quoted on whichever one. So your viral performance is quoted on the per performance. So if you remove MS-2, remove or kill MS-2 at 1 log, but your 5X174 is removed at 5 logs, they still quote the 1 log treatment. So you need to basically be able to work with both. Okay? So basically what you would ideally like is a 3-star rating, which is very, very hard to get for your technology. There is a newer version of this that was released a few weeks ago. But if you get, that's actually 3-star, but if you get 3-star, you remove the required 4 logs of E. coli or kill, and at least 5 logs of viruses, and you remove or kill 4 log of protozoa. So basically, as you go down the list and have less stars, you're removing and or killing less of the indicator organisms for water treatment. So these are just chosen, E. coli is chosen because it's responsible for childhood diarrhea, and it's an important fecal contamination indicator. Cryptosporidium is a very important pathogen. It's actually sensitive to UV light, but it's very disinfection resistant, for example, chlorine. And one of the important things is they represent a range of particle sizes, and they each have very different biological and surface properties. So the viruses are the very, very small ones. Thanks. So you know this from your last presentation that Natalia gave, but basically E. coli are bigger, and Cryptosporidium, the protozoa, are bigger again. Phage are parasites. They can't reproduce by themselves. In our case, they need E. coli to grow, and you cannot remove them by standard filtration. So you've seen that picture before, so we'll just go on to the next one. So basically, again, rotavirus is an important pathogen for childhood diarrhea. It's easy to grow them in E. coli, and 5X174 and MS-2 are actually relatively similar in size, but quite different. As Natalia said, the importance of lacking the coat is actually very important during the processing step. You saw the E. coli growing inside and bursting the E. coli. Well, a lot of the E. coli will have burst. There'll be a lot of E. coli there that haven't yet burst. So you need the chloroform to basically burst the E. coli. And importantly, because they don't have that lipid coat that Natalia says, the viruses aren't affected. So you can use chloroform to basically increase your yield of 5X174 and MS-2. So you've seen that already, so we'll just go to the next slide. Importantly as well, MS-2, 5X174 and MS-2 are both relatively easy to grow, but you get a higher yield with MS-2 than 5X174. So I'm finding I get MS-2 to 1 times 10 to the 12 per mil, whereas with 5X174, it's still high, but it's maybe 1 times 10 to the 9. So it's a few logs lower the yield from 5X174 than MS-2. So MS-2 is used a lot because of the massive yields that you get from it. It's also used as a conservative model for absorption, and also it's UV resistant. So just basically see how UV resistant. So this just basically indicates UV resistance and that MS-2 has there at the bottom. The wavelength's 254, and that basically to get a 4 log kill, MS-2 has a dose of 71, whereas you can see the other ones, you're looking at 5X1747 with UV. Cryptosporidium's very easily killed with UV in comparison. And I just put in some other pathogens there, E. coli 0157 and Campylobacter jejuni, just because they were in the same document. So you can see there the message is, basically if you can kill your bug, if you can kill MS-2 with UV, you will almost certainly kill any other pathogens that are there. So the important thing is this is focused on growing MS-2 now. You need to make sure you have the correct strain. So make sure when you go to grow your strains, confirm with ATCC in your documentation that it definitely is 15597 and that the corresponding phage is 15597B1, and that they haven't sent you 2 vials of E. coli and you don't have any phage. You just need to check what they have sent you and the certification. And if you employ good lab practice and work aseptically, you will be fine. It is relatively straightforward. So I just wanted to explain the protocols. Over the last few weeks in Contorazole with Hector, we've been working on revised versions of protocols for Contorazole. With Contorazole, so basically the growing phase from purchased ATC vials, that's what we've basically called it. Phage and the bacterial host are both supplied in freeze-dried form. Hector, when he purchased his, got 2 vials of each. So what he's doing is we've used 1 to grow the phage and he's keeping his other as an emergency backup in case the freezer goes down and he has vials of freeze-dried host and phage so that he can grow them again if something goes wrong, if the freezer goes down over a weekend or something happens. So basically you should only have to do the growing phage from purchased stocks once. For that you just use agar plates and top agar, and there's a wee video coming up of that. You make your master stocks and your E. coli stocks of phage and host, but you don't touch your master stocks of phage. They're kind of your backup in case something happens, your bulk stock. The bulk stock is grown up in broth and you use that for water treatment experiments, and you need to maintain your stock levels, and you can use that as an inoculum to make more bulk stocks. Okay, so basically you also don't forget to maintain your E. coli as well. I use glycerol stocks at Ulster University, and so will Hector. That's personal preference. I think Natalia's using glycerol stocks too. There are different methods of preservation, obviously, of bacteria at E. coli, but as long as you use a method which suits you and you know it's the right strain of E. coli, that's fine. One of the things these protocols have is they're currently in English. They're with more pictures, and basically Hector, obviously I'm not going to write them in Spanish, you wouldn't want to read them, but Hector is going to write them in Spanish as well and share them. And we also put in lab checklists just so you can tick and see. And also I think it's timely we have a phage kind of WhatsApp group. So we're going to try and start that and help each other out more over the next few weeks too. Okay. One of the things as well is the working stock of E. coli, it's just an overnight culture. You just grow E. coli overnight in broth, and you just harvest it and centrifuge it and resuspend it in half the volume that you grew it in overnight. And then basically resuspend it in PBS and aliquot that into Eppendorfs basically. And you use that for your growing your phage, counting your phage, and that's what a top agar looks like as well. Okay, so we're just gonna, next one. So basically, one of the things we did, the master stock and doing that worked no problem at all at Contorazole. We got a nice high yield, and that's frozen away in the -70. That worked by basically putting a water bath onto a shaker. The water bath was set at 37 degrees. We had to be careful if you set it too fast, the water would, fly up over it, so it wasn't at 200 RPM. We also grew it in a smaller volume, so at Coleraine we have 5 litre flasks. We grew it in a 1 litre flask and just used, instead of 1 litres, we used 0.2 litre because you want enough room for the broth and the culture and the phage to basically have enough room for oxygen and not be up near the top of your flask as well. One of the things that was important was the yield from the bulk stock that we got was the same yield that you get from 5X174. It was 1 × 10 to the 10 and not 1 × 10 to the 12. So that's the one done in broth. Basically, that's because I think we broke Hector's stirrer, the weight of the water bath on it. So yeah, I would recommend you basically get an incubator. That's like the one we have in one of the ones we have in Coleraine. So your flasks slot in there, and it shakes at 200 RPM, and you can also put plates at the count if you're at the top, if you're counting your phage as well. So Hector might not buy an incubator as big as that, but we might look at getting a small shaker, and then I'm very confident he will get 1 × 10 to the 12. What we did have was we had kind of manual shaking, so we had it sitting in the 37 degrees water bath, and then one of us would walk over every half an hour and give it a shake. But we got 1 × 10 to the 10. So basically as well, we just harvested that in smaller volumes, obviously, Falcon tubes, and still added 10% chloroform too. So it worked to a point, but actual shaking incubator we think is pretty important. So how often do you have to make up your bulk stocks? It's determined by your workload and storage conditions. So I've been doing stability trials, and I've found that the advice is for long-term storage from ATCC, freeze-dried, which we don't do. Liquid nitrogen, too expensive, don't do, have to pay for it extra. So what we do is we use a -80 freezer at Coleraine, and that's fine. Natalia said there isn't really access to a -80 freezer. So I've been looking at the stability of the host E. coli and also the phage at -20, and they're both fine after 6 months. So it basically means you should be able to, you'll just have to rejuvenate your stock at least, no more than once every 6 months. Depending on your workload, basically, if you use different water treatment volumes, the top one there is 20 litres, the bottom's 400. Now this is based on a yield of just over, about 220 mils. So you'll see there that if you do get the 1 × 10 to the 12 per mil, you will get a lot of treatments. And I basically have used a 1 litre volume. So that basically means if we spike it 10 to the 10 per litre, as per recommended by WHO, we'll actually get more than 5,000 reps in a 20 litre volume. And in a 400 litre volume, if we spike it 10 to the 10 per litre, that's according to the WHO protocol that I mentioned at the start. You need to spike above a certain level for your effectiveness to be assessed by them. So basically, if you do the 1 litre volume, you'll get more than 250 replicate treatments with a 400 litre volume. So you can see you do get a lot of replicates there, even with a large treatment volume. So if you can, have a shaker incubator and try and have a large flask too, because then you have to do this less often. It's probably important as well because it's a full day. So basically, you do overnight cultures, and then you incubate your E. coli for an hour in the flask, and then you add your phage, and it's another 5.5 hours, and then you have to harvest it. So if you can have a large flask and a shaker, then you spend less time dedicating a whole day to basically growing it and harvesting it. So basically, again, the chloroform that I mentioned, it's important you have a safety cabinet for that, Ecosaur do. You increase your log and you mix gently by swirling for 10 minutes at room temperature. Allow the sediment to settle. You see what I mean in the next slide? This is from the bulk phage. So basically that particulate matter there, don't just pour all out when you're harvesting it. Allow it to settle and spend about 5 minutes pouring off the supernatant. You will save using as many of the syringe filters which you use in the cleanup, and you can reduce your centrifuge time as well. Just make sure if you're doing large volumes, use solvent-resistant centrifuge containers. If you do pour it all in, this is what I did the first time. So you can see the huge big pellet. And basically it doesn't form a proper pellet anymore because of the chloroform extraction. It's kind of stringy up the side. And if you do try and pour it off, it's very, very hard to remove the supernatant from the pellet. And whenever I did that, in the end, it took me 3 hours and 4 boxes of syringe filters to process it. So don't do that. Okay. So, we'll just watch a video now. This is of Natalia when she was in, it's just in the, it'll be in the, yeah. This is of Natalia when she was at Ulster Coleraine, just growing phage in the top agar, which is where you put your E. coli working host and phage. There might be sound. Yeah, that's it now. So basically 50 microliters of E. coli and 50 microliters of your serial diluted phage. And then you just gently mix as before, and then just pour them in the order your plates are labelled, just to the and then just rock gently and start off pouring them in the middle, and then just okay, and then the next one, and then again just pour in the middle, pour gently and rotate. Perfect, and then that's fine. And then put the lid on and leave to dry for about 5 to 10 minutes. And then mix again, and then just pour in the middle, and then mix gently, and then you're fine. And then could you just rewind it a wee bit and pause it? Just play it, but then pause it. Not actually. Yeah. So basically, each one of these is it's called a TSA agar plate, which is media commonly used to grow E. coli. Each one of these plates has been in an incubator. We keep them in the fridge, and that's also in the protocol to keep your media in the fridge for a few weeks after you made it. So if you take it out of the fridge straight away and use it, your top agar, which is melted, can set too quickly. So you're better off keeping your TSA agar plate, which is the base for the top agar. The top agar then just contains your phage and your E. coli, and then you just basically mix and gently pour, and then the next day you should see phage. So, yeah, that's it. Sorry. That's okay. Just, yeah. Thank you. So basically then the top agar, the TSA plate stays the same whether you're growing or counting phage from water treatments. So you'll notice from the protocols, when you're growing or counting phage, you use a slightly different percentage of agar. That's just because for water treatment, you have a 1 ml volume, and your water, your treatment, basically your treatment water contains your phage, and you serially dilute that out, and you need a larger volume of E. coli as well. So for growing, the volume of phage and E. coli are equal, and you have less agar. And then for water treatments, you have more agar and a larger sample volume, and basically then a slightly, double the E. coli working stock volume. It's important to remember as well where you're counting your phage, you want to count that in triplicate. So it's the same as doing bacterial counts, where you have 3 plates of a serial dilution, where you have 20 to 250 PFUs. That basically means you can trust the number that you're counting. So where you're counting, try and count in triplicate, and you also want to check that your controls are correct as well. I'll just go through that as well. So basically it's very important, especially when you're doing phage for the first few, you need to do it every time, but you really need to do the control plates. So the first control plate I do is E. coli with just PBS, and this should have a complete confluent mat or lawn of bacteria and be totally opaque. And then I just do contamination checks with PBS, which is your serial diluent, and MS-2 coliphage, which is just the phage on its own. Because there's no host there, it won't grow, and it's kind of just like a contamination check. Those should be clear as CFUs. They're really, really important to do, because the first time you grow this phage, if you go to the next plate, at very, very high dilutions of phage, it actually looks like there's no phage there. It kind of looks clear, nearly like the control plates, but actually it's nearly like granulated or dissolved sugar. So you need to do the serial dilutions, because if you don't, and especially if you're doing water treatment models, you basically might think, oh, there's no phage, I've killed it all, but you haven't actually diluted it out enough to see those kind of plaques there and the phage. So the serial dilutions are actually very, very important to do, especially at the start when you don't know, you're not familiar with growing phage and the appearance of it on a plate when you have it in your hand. So again, so you go from too numerous to count to 20 to 250, and then you should see lower numbers. Just be careful as well, whenever you're adding your E. coli and phage to your top agar, make sure it's all melted. Natalia's going to use a microwave to melt her top agar. I use a microwave in Korean. Hector's using beakers of water heated up on a hot plate. I think Helen uses, So we all use different heating methods. The main thing to do is if you have a big run on that day, you can melt 30 or 40 or 50 top agar bottles in one go and keep them in a water bath for a few hours. And then you can basically do them, with the Sierra dilutions. I don't really do any more than 6 at a time in the hood. So I don't have any more than 6 agars at a time in the hood. So I would just do 2 replicates of 3 for the serial dilution counting. We'll not get into the calculations, but basically the calculations are in the protocol. You basically work out the number of PFUs per mil. You should, for your MS-2 master stocks, you would expect to get at least 1 times 10 to the 9 per mil probably. And for your bulk stocks in liquid culture, whenever I've done it, I've got 1 times 10 to the 12. And I've now done it a few times, and the stocks are in the -80 freezer. And Helen, importantly as well, has replicated that 1 times 10 to the 12 in the counts as well. So we know it's pretty accurate. If you get a funny calculation where you get 1 times 10 to the 14 or 15, you probably have done something wrong, because you get to a point where it's physically impossible to get that many phage. So if you get 1 times 10 to the 13 or more, you might have done something funny with your dilutions or your calculations. So my boss, Professor James Dooley's growing a lot of phage, and he informed me of that. I didn't actually do that, but you get to a certain point where if you get 10 to the 14, 10 to the 15, you've probably made a mistake in your calculation, and you can't actually get that many phage per mil. So I think that. So thanks to Hector for working with me for the last 3.5 weeks now, and especially to Consortia as well. So that's it.
Okay, time for questions, please. Patrick.
I just have a comment that this is, as you can see, quite complicated. And part of the capacities and capabilities is for us at Ulster to share our knowledge. So Bill and his professor are an expert in working with these little tiny viruses. If you imagine a balloon, a long shaped balloon, it's about the size of a bacteria. A little piece of glitter inside that balloon would be the equivalent size of bacteria and viruses in the real world. So viruses are super, super small, but can cause real bad illnesses. And if we only focus on bacteria with our treatment devices, it doesn't mean that people are safe. It doesn't mean that water's safe. So as Bill is describing here, we're trying to use those viruses as a marker of the effectiveness of the treatment. So if we can kill this MS-2 virus, it means that we will kill the vast majority of the bacteria and the protozoans with the UV treatment. What Bill didn't maybe say at the start was the technology we have chosen for the treatment of the water is filtration, followed by UV disinfection. We're not intending to use chlorine because, as we talked about yesterday, it's just not acceptable for the people to use consumable chemicals. So to be able to describe and to use our expertise at Ulster to help all of the other partners in Mexico, Colombia, and Brazil to be able to do this work is quite important. It is complicated, but it's very valuable for everybody in the organisation to be able to test their own devices against what is the most important marker of infection or unsafe water, as opposed to safe water. So I just want to let everybody know that this work is ongoing, and we're trying to share our knowledge. Every time we go from Ulster to Cantara or to CTA or go to the field, we discover 1,000 new things that we could do. So this is not a one-way transfer of knowledge. And as Bill describes then with the shotgun sequencing, I think we must have at least 1,000 different ideas of the potential of those different technologies and techniques to try to help bring more support and more value to the partners that we work with, because there are more grant applications. So it's just to put a bit of context behind the work that Bill will describe. And it's the same for what Natalia will show after coffee. We have learnt a huge amount from Natalia and Lita's expertise on the protozoans, the way it was described yesterday in one of the presentations about killing the cysts, you remember? Natalia has also helped transfer knowledge then back to Ulster. And this is what we try to capture in this capacity and capability, this transfer of information and this building of the network and the communities to do our research. Oh, Helen.
Just Bill question. I have a privilege to use your stock that you prepare for me for meals, 10 to the 12 PFU. But I have a master glycerol stock in my freezer, -80. In worst case, if something happens, how people can perform initial stock for treatment from master glycerol stock? Is they need to use fudge buffer that require a lot of reagents, or they can do a simple PBS? And do you know what's the difference? Maybe stability of culture is different?
I would just try and grow up bulk fudge. So if you have 15 mils of that, at anything like 1 × 10 to the 12 mil, then you just add that to your culture of E. coli. And so you'll have a litre of that in a 1 litre flask. And you add 15 mil of fudge to that, and then by the end of the day, you'll have another litre of 1 × 10 to the 12 fudge. I would basically keep your master stocks as an emergency backup in case something happens, your working stock. Now, I know not every place has the facilities to do this, but obviously if you have access to more than one freezer, you're better off storing your stocks in, a few different freezers and then doing as Hector's doing as well for the kind of Armageddon experience where somebody accidentally turns off the freezer or there's a power cut and it's not on an emergency backup supply, then you still have your freeze-dried stock of ATCC. Now, I didn't buy in 2, I just bought in 1 of each, but Hector bought in 2, which makes sense as well. And if you keep that in the fridge, because it's freeze-dried, it'll basically keep well after SafeWater. Well, no, well, basically, I just call them master stocks just because they're really backup stocks. They're just kind of there in case something happens. You're working treatment stocks, but that's what you do to get your fudge up and going and grow it on just agar plates with top agar. You just need that to make your you need to have your master stocks, but then also that's used for your inoculum to make your bulk. So you need 15 mil of that if you're growing up a litre of your master stock to basically inoculate. Sorry, this is a bit complicated, but you need that to put in to grow your bulk. And then whatever you don't use to make up your bulk, then you just freeze that, and I just call that a master stock.